Hey fellow lab rats, this is Rebecca from the Lab Rat YouTube channel. In this video I'm going to be discussing the use of the brightfield microscope. Alrighty, let's get started. There are a variety of different microscope types, but the primary one we use in medical laboratory science and histology is the brightfield microscope, which is also called the compound light microscope. What a compound light microscope does is uses a light to illuminate a sample to create an image. So a sample is placed onto a glass microscope slide, which is then placed onto the microscope. And the microscope then illuminates this slide via a light source. It's usually either a halogen lamp or an LED light source. And this light passes through the sample on the slide, and an objective lens magnifies the image and projects that image onto an eyepiece. So when looking at a specimen, the image appears dark against a bright background. So this is why compound light microscopy is often referred to as bright field microscopy. The photo on the right-hand side of the slide shows what a generic compound light or bright field microscope looks like. It's very important that you understand the parts of the compound light microscope to succeed in the laboratory profession. So this is a photo of one of the microscopes that I use in my student laboratory. Specifically, this is a Primastar 3 scope made by the company Zeiss. So let's talk about just the different parts here. So this first part here is the stand, and this helps to provide stability to the microscope, and it also provides a frame for the objective and the eyepiece. The next part here is the base, which is right here. This particular microscope is integrated with a fully digital classroom, and it's connected to a network, so we don't move these around in the laboratory. But if a microscope does need to be moved, one hand needs to be on the base, and the other hand needs to be on the stand for transporting it. Next, we have the ocular lens, which is also known as the eyepiece. I'll talk more about the ocular lens within this lecture, but in short, this is what magnifies the image produced by the objective lens so that it can be seen with the laboratory professional's eyes. This is the nose piece, so this is what holds the objective lenses. It can be rotated easily to change the power of the objectives. These are the objective lenses. I'll discuss these later on, but these usually consist of 4x, 10x, 40x, and 100x powers. These are a way to relay an image of the object on the slide to the ocular lens. Next is the stage. So this is the flat platform where microscope slides are placed to view them. If you see the metal colored pieces on the stage, those are the clips that help to hold the microscope slides in place. This is the condenser, so the purpose of this is to focus the light onto the specimen. And of course, here is the light source. So we also have a light control, which is here. This is going to control how bright or dark that light is going to be coming from that light source. Then the fine and coarse adjustment. The coarse adjustment knob is used to bring the specimen into near focus. The fine adjustment knob is used to sharpen the focus quality of the image of the specimen after it has been brought into focus with that coarse adjustment knob. This is the back of the Primastar 3 microscope. Again, this is a microscope that has digital classroom capabilities, and what that means is it connects to an app called LabScope that allows the app users to see the view of each microscope in real time if connected to the network. You can also take photographs and save them to the computer. So on the left-hand side photograph, this grayish kind of blue-hued cord here is the cable that connects the microscope to the network. The black cord on the bottom right-hand side of the scope is the power cord, and then on the bottom left-hand side of the scope is the power switch. So I've enlarged a photo of what this power switch looks like on the photo on the right-hand side of this slide. So when the microscope is not in use, it must be powered off. And let me just use a pointer here so we don't get confused. So that cord there is the cord that connects the scope to the network. If you're using just a regular compound light microscope that doesn't have digital classroom capabilities, that cord doesn't exist. Here is the power cord here, and then of course this is the power switch that controls whether or not the microscope is on or off. Most microscopes will come with a dust cover. This blue cover is the dust cover that came with the microscopes I have in my student laboratory. These covers prevent buildup of dust and any other debris. Anytime the microscope is not in use, it must be powered off and the dust cover must be put on the microscope. The ocular lens is also referred to as the eyepiece or the oculars. This further magnifies the image. Generally, this is an additional 10x magnification, although some can magnify up to 30x. If you see here in this white lettering on the ocular lens right here, okay, so there's a 10x written here. This means these ocular lenses will further magnify the image by 10x. The objective lens is the part of the microscope that is needed to produce the base magnification. It relays the image of the object into the eyepiece. There are varying powers of objective lenses, usually 4x, 10x, 40x, and 100x powers. Recall that the nose piece is what holds the objective lenses. It can be rotated easily to change the power of the objectives. So this here is the nose piece, okay? You need to rotate between the powers by rotating the nose piece. You do not want to touch the objective lenses, so only move the objective lenses by the nose piece. The objective lens that is in use here in this photo is the 4x objective lens. Okay, so you see how this says 4x on it here? That means that it has 4x magnification, and we know that it is the active one because it's right over where the microscope slide goes and where the light comes through on this microscope. So that's how we know that's the active one. The photo on the far left-hand side of the slide shows the active objective lens as the 10x objective lens. So if you see here, 10x, okay, that means that it's the 10x objective, and we know it's active because it's right over where the light is going to come through, okay? And these get rotated by this nose piece, okay? The one in the middle shows the active objective lens as the 40x objective lens, and you can see it here, 40x. And we know it's active because it's right over where that light source is going to be coming through on to light up that image. And the photo on the right hand side shows the 100x objective lens being the active objective lens. So you can see here it says 100x, and it's right over where the light is going to be coming through. So we actually refer to this 100x objective lens as the oil immersion lens, and you can see here it actually says oil. Okay, this is an oil immersion lens. So this lens requires oil to be placed on the slide for viewing. The oil helps to increase the resolving power of the microscope. I will show how to use this in future slides here, but it is important to note now that oil can only be used with the oil immersion lens. So that is the 100x objective lens. The other lenses cannot have oil on them. It will actually ruin them. So make sure that oil never comes in contact with any other lens other than that 100x lens. All right, so we've talked about the objective lens and the ocular lens, all right? So we need to take both the objective lens magnification and the ocular lens magnification into account to determine what the total magnification of the specimen is. So to get total magnification, the magnification of the objective lens must be multiplied by the ocular lens magnification, right? So this is a table that breaks down exactly how you need to figure out how what the total magnification of the scope is. So if you are using the 4x objective lens, okay, so it's 4x, you need to multiply it by the ocular lens magnification, which is here. Now, if you notice, all of the ocular lens magnification in this table is 10x. And the reason for that is, remember, if you go back to the ocular lens slide, we have 10x just it's just a static thing. It's never going to change. The ocular lens on most scopes is going to be 10x. Now recall, we can have it up to 30x, but a large majority of all compound light microscopes are just going to have a 10x ocular lens magnification. So basically what you need to do is take all the objective lens magnification, so depending on what one you're using, 4x, 10x, 40x, or 100x, and remember this 100x is that oil immersion objective, all right, and you want to multiply it by 10. All right, so the total magnification of the sample, or whatever you're looking at under the microscope when you are using the 4x objective lens, is 40 times the actual size of whatever that sample is. When you're using the 10x objective lens, it's going to be 100 times the original size, the actual size of whatever you're looking at. If you're using the 40x objective lens, it's going to be 400 times the magnification of, so 400 times larger than what the actual size of whatever you're looking at is. And then of course the oil immersion lens, which is the 100x objective lens, you are going to have a total magnification of 1,000 times. So this means that whatever you're looking at in the scope, it's 1,000 times larger than whatever it actually is. Hopefully this chart helps you. The condenser is beneath the stage and above the light source. The condenser is the part of the microscope that concentrates the light source into a cone of light. This concentration illuminates the specimen with a uniform intensity of light. You'll notice here in this photograph that there are 100x, 40x, and 10x markings on the condenser. So this is what I'm talking about here. Okay, so these correspond to the objective powers. So the condenser needs to be adjusted to whatever objective lens is being used. So for example, if you are looking at a specimen using the 100x objective lens, the condenser needs to be set to the 100x setting on the condenser. So right below this condenser is the light source. So here's the light source here. Okay. This knob, as denoted by the arrow on this photograph, controls the intensity of the light source. This controls how bright or dark the light is that illuminates the specimen. As denoted by the arrows in this photo, these two knobs are the coarse focus adjustment knob and the fine focus adjustment knob. The coarse focus adjustment knob moves either the stage up closer to the objective lens or down farther away from the objective lens. The fine focus is used for slower, more precise focusing. This shows the microscope stage. The photo on the left-hand side shows the stage without a microscope slide on it, and the right photo shows a glass microscope slide that is properly on the microscope stage. I've outlined some steps of how to use a microscope in order. First, the dust cover needs to be removed. Ensure that the microscope is plugged in to a power source. Then the light source must be turned on and the brightness of the light source adjusted. Ensure that the stage is all the way lowered, so this can be done by using the coarse focus adjustment knob. The slide with the specimen needs to be placed on the microscope stage. You want to start with the lowest objective lens first, making sure that the condenser is of course set to the corresponding power level of that objective lens. Next, while looking into the ocular lens or eyepiece, use the coarse focus adjustment knob to bring the stage upward towards the objective lens, stopping when the slide image comes into view. Then use the fine focus adjustment knob to focus on the specimen. If a higher magnification is required, use the nose piece to go to a higher power objective lens. At this point, only the fine adjustment knob can be used for focusing. If the coarse adjustment knob is used at this point forward, the slide can be crushed. If the 100x objective lens is needed, oil must be used. And oil can only be used for this oil immersion lens. This photo here shows the proper application of oil on the microscope slide. The slide must be cleaned before going to other objectives if indicated. Again, oil must be cleaned off the immersion objective lens after every single use. Lens cleaner and special lens paper must be used. Some people and some labs use Kim wipes. I find these to be too coarse and have seen them damage lenses, so please do not use Kim wipes to clean the scopes in our student laboratory. If you're another laboratory and your laboratory allows you to use Kim wipes, I guess go for it, but I don't allow them in my student laboratory. After you've cleaned the lenses, the scope needs to be turned off. Depending on what laboratory you're in, it may need unplugged, and then of course the dust cover put back on the microscope. All right, so that concludes our lecture on microscopes. If you liked this video, go ahead and give it a like, and please consider subscribing to my channel for more educational laboratory content. Until next time.